Hi everybody, this is the last part for the quiz that you're going to take on Friday for Chapter 7. So I'm posting this online here on Tuesday morning. You need to have watched this for Wednesday's class and have taken notes on it. I want you to take notes in your notebook on this, or you could do it on the back of the paper I gave you yesterday. It really deals with a lot of the proportionality pieces related to triangles. So the section is 7.4, parallel lines and triangles. First thing we need to talk about is the definition, the theorem that's going to cover us in the first part of today. And it's right here. You're going to want to pause the video at some point to take down the definition. And what it says is, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. Okay, it's a lot of words. What do they mean? Let's use this figure right here to kind of show what it means for that. If a line is parallel to one side of a triangle, okay, so that we have this line parallel to this side of the triangle, right here. Parallel. We've got our parallel signs in. And it intersects the other two sides. So it intersects this side and it intersects this side right here. Then it divides the sides into segments of proportional length. So what it means is PS and SR, PS to SR is equal to PT to TQ. Those ratios are proportional. And that's what we did in class yesterday. We really worked on proportionality with our side lengths. So PS to SR, this to this, PT to TQ, this to this. And then we do a proportion, because in this case you're given three of the side lengths. 7.5, 3, 2.5. We need to find this length. That's the question, and that's some of the practice we'll work on in class on Wednesday. So we're going to find that. So this is to this, x is to 2.5, as 7.5 is to 3. You know cross products. 3x equals 18.75 when you do the multiplication. X is equal to 6.25. That's an example of one of the ones we'll do in class. So this is the first of the theorems that we're doing. And next to it right here is the converse. The converse asks, are the lines parallel? Well, we have to see if these relationships are proportional. And if they're proportional, then the lines are parallel. It's the converse of what we just did. So, if we have this triangle and we have a segment, we're trying to find if these two lines are parallel. This length is 3, this length is 9. This length is 1/3 of this length. 1/3 of GF. So we set it up. 3 to 9, 1/3 to 1. 1/3 is 1/3. So yes, we can say that these two lines are parallel. Okay, so that's the converse. I'm going to move the video a little bit. For the last part. Okay, now we're going to start with a special term called mid-segments. A mid-segment is special in that it's the midpoint of two sides of a triangle. Here's the example. This is a mid-segment. That means this side is congruent to this side, and this side is congruent to that side, this length. So what it does is it cuts this segment in half and that segment in half. They're connected. We have a mid-segment. Okay? So that is the definition of a mid-segment. Here's the theorem that goes along with that. A mid-segment of a triangle is parallel to one side of a triangle and is half the length of that side. Okay, so let's visually go through that. A mid-segment of a triangle. So this is our mid-segment. It means those are congruent. It means those are congruent because it's the mid-segment. Cuts it in half. It's parallel to one side of the triangle. So that means we have a parallel situation with those lines. So that's one of the conditions that happens when we have a mid-segment, and is half the length of that side, half the length of this side. So if this length is 10 FG, then JK is 5. So this length is going to be half of this length. Okay? So there's two special things that are happening with a mid-segment. It creates congruent segments there and there of the other two sides, and that it's parallel to. And it's half the length. So whatever this length is, this is half of that. Okay? So you need to have these notes down because tomorrow in class before lunch, you're going to be working on some problems here too. As a reminder, a couple of you didn't finish that work from yesterday in class. You've got to have that done walking into class tomorrow too. Okay? So go back and watch this video again if you need to remind yourself so that you're ready on class tomorrow for the parallel lines. I want to add one more thing. It's going to ruin my chance to win an Academy Award for this video because I forgot to add one thing on these. Okay? When you have parallel lines, this is your transversal. And so that these angles right here are same side interior angles, right? So remember, same side interior angles of parallel lines are supplementary. They add up to be 180. So remember that. It also means that if you extended this out a little bit, this angle and this angle are congruent because they're alternate interior angles. Okay, so those rules from parallel lines still apply. All right, I will see you in class tomorrow.